Hello bitches, how y'all doing? Funny thing is, as I opened my webcam and I recorded a whole lecture for this already, and I found out that my webcam was in the way of the code and you guys couldn't see anything. So I had to delete it and re-record it. And now you guys are missing out my face because I removed it. So, oh well. My beautiful face, y'all won't see it. Anyways, this is the first lecture of computer science programming workshop C++. The first thing is pointers. Pointers, pretty simple concept. We're gonna go into right now. First, I'm gonna start my code. Right. And so here, I'm gonna initialize the variable. Right? Now the way I initialize this variable, this is in the stack, which is right here. Right? This is what I initialized. It's somewhere in the stack, and it has the value 100. This value, it has the value of 5, but the 100 is the address of this, wherever this is stored. Right? That's in my stack. Now, what's the difference between a stack and heap? Heap, as the code is running, it can keep adding things. The stack, as soon as the code compiles, you cannot allocate more memory in the stack. It's set in stone. But your heap is, you can change it as like dynamically as the code runs. That's the only difference. Today, we're going to be focusing on the goddamn stack. Now, obviously, I have this, and here I'm going to create a function. Now, this function, the only thing it's going to do is it's going to change my number to 15. And I'm going to call it here. Oops. And this is going to be num1. And obviously, I'm going to print num1. Whoops. I'm a little bit rusty when it comes to typing, unfortunately. Okay. So, what am I doing here? I'm passing num1 in here. Num1 goes up here. And then I increment it to 15. And then I print it. So technically, it's supposed to be 15. But you see when I run it, where's my run? Hello? There you go. Okay, so you see here now, it printed 5 and not 15. And so the problem is, what I passed here is what num1 is, which is 5. Right? This is what I did. And so when it went up here and it changed, I just changed 5 to 15. I didn't change this actual value. And so, how do I change this actual value? Well, there's two ways. One way, I can tell the function, whatever I pass here, take the address of it. So now I took the address. What I took is this 100. And so here, when I change the number, I'm changing what's at this 100. What's in here. That's what I'm changing. Okay? And so now when I run this, as you can see, 15 instead of 5. Now that's one way to do it. Second way to do it is, what if I pass the address directly in here? Right? I'm passing the address of num directly in here. Then what I can do is something called a pointer. Okay? Now before we do this, let me actually explain more about pointers. Let's keep this the same. And I'll explain more about pointers. I go here and I create a pointer. What a pointer means is it doesn't hold values, doesn't hold an integer, doesn't hold a string, doesn't hold a character. It only holds an address. That's the only thing it holds. So when you make a pointer, you put asterisk. You can name this pointer, you can name this ass, you can name this anything. Potatoes, if you know what I mean. But okay, and so I'm gonna name it pointer. Now I created this, right? So I've already written this out from last lecture. This is what I create. Oops. Right now, it's not holding 100. It's not holding anything. This is what it looks like right now. Right? And it's obviously stored at some address. So remember, when I did this, I passed it the address of num1. Now I could do the same thing. So I could say here, Now this should print me the address of this part. Okay, so that's what this means. It gives you the address of anything. Okay, now what I want this, remember this only holds addresses. So can I make it hold the num1 address? Yeah. Let's say equals num1. Now this pointer holds num1 address. So as you can see, if I print both of them, right? Now if I put both of them, which is the address of num1 as well as the value of pointer, this will give me the same address. You see what I mean? Same address. And so because obviously the pointer equals the address. Now, how do I access this number? Well, I know if I do this, num1 will point the number. But this pointer holds the address. So can I tell the pointer, hey man, you're holding this address. Can you go to this address and get me what's in there? And so the way you do that is called dereferencing. When I put the star, what I tell it to, so right now it's holding the address of num1. Right? So when I did this, what I did basically is this. I took the address and I put it in here. Now what I told it, when I put the star, what I told it is, hey bro, can you go in that address that you're holding and tell me what's in there? And so that's why, oh shit. That's why it printed 5. Okay. Now, can I do the same thing with the function? And so remember, for the function, I have to pass it num1. This is passed by value. I'm not passing num1, I'm passing its number, which if I change it, it doesn't change. Now if I do it like this, I'm passing an address. And when I pass an address, I can manipulate it. Now, obviously, let me fix that. Obviously, right here, it says what you're trying to pass is an address. And this doesn't expect an address. Now, obviously, we said a pointer can hold an address. So can I make this into a pointer? So it holds this address? Yeah. Because what this is equivalent to is me saying, that's what it's equivalent to. I'm saying this is equal to that, which is valid. I can do it. This pointer equals to this. And so now that I got the address, you see here it's an issue. It tells me I can't do this. Why? I got the address. Can I change what's inside? What I'm doing here, this number equals not 5, but it equals 100. It equals the address. And so how do I access what's in there? Remember here we said, if I dereference it, I'm telling it, hey, can you go to the address you're holding? So here, when I dereference it, I'm telling it, hey, can you go to the address you're holding? And so it goes to this address. And I'm telling it, change what's in there to 15. You see now when I run this, 5 and oops. What's going on here? Dereferenced 15. Oh, I didn't print it. I was about, oh, am I wrong? No way. You see now, if I rerun this. See, first it was, you see this printed 5, this printed 5, which makes sense. Then I changed it, and then I printed it. And it changed to 15 because I changed what's at the address. Now there's one more way you could do this. I can pass in a pointer. Remember, my PTR, you see this dereferenced, but my PTR itself holds that address. So me passing PTR is the same thing as me passing this. PTR literally equals this. So I can pass it, and I use it like a pointer, just like I did. And so this is the benefit of passing by reference, is because when I pass by value, you're going to think, yeah, why is this pass by value? Because when I do this, what happens is this function, let me fix this back. Now what happens is this function, I passed in 5. Now you might think, well, where does this 5 get stored? So what the code actually will do is inside this function, it'll be like, okay, num, so here I have, remember, and I'm passing it 5. So what it does, that's what it does. And so obviously it increases the space and it takes up space. And so if this was a 10 gigabyte array and I pass it by value, I pass the value of the array, then I'm gonna copy 10 gigabytes. What the fuck? And so since I'm gonna pass it by reference, I'm referring to its address. So you can go manipulate it, add the address instead of copying. That would be fine, right? And so because then I wouldn't be copying, I'd be manipulating it where it's at. Okay, so that is pointers in a nutshell. I hope that helps. One more thing before I end the video. You can also do pointers up pointers. So what I can say is this. Now, what is the issue here? This can only, well, let me name it a new variable. This can only point to a pointer. Like, remember how this pointer can only point to an address of a variable? This can only point to an address of a pointer. And so this equals this. So right now what I'm doing this. But it can't equal a value, it can only equal a pointer. And so I'm going to pass it the address of the pointer. And you see now here, this pointer 2, well, for us is pointer 1. This pointer equals this address, this 106. Okay, and so this basically comes here. And now what I can tell it is if I dereference it, so if I do pointer 1, so I'm doing this. If I do this, it will give me this. If I dereference it once, what does that mean? That means go to the address you're holding and tell me what's in there. So we'll go to the address it's holding, tell me what's in there. Now what's in there? The address of num1, right? So I'm gonna go to this address, tell me what's in there. 100, address of num1. And so if I dereference it one more time, what am I telling it? Well, first, go to the address you're holding and tell me what's in there. Go to the address you're holding, tell me what's in there. It's 100 in there. So now this part becomes 100. Now I'm dereferencing that one more time. So I'm telling it, okay, now go into the 100 and tell me what's in there, which is 5. Okay, and you see now, when I do this, I run it, this also prints 5. Okay, so that's pointers in a nutshell. I hope that explains it. Thank you for listening, and I'll see you in the next lecture.